last time we were looking at intersection of lines. We looked at intersection of lines and we were able to find the point of intersection of two lines. Okay. As we indicated earlier, we said to find the point of intersection you have to solve the two equations given simultaneously. But today we are on a different topic, which are parallel lines. And for parallel lines, we see that parallel lines have the same gradient. Okay, parallel lines have the same gradient. Or in the other way around, we can say lines with the same gradient are parallel. Lines which have the same gradient. Okay, lines which have the same gradient are parallel. Or parallel lines have the same gradient. Basically, that's what parallel lines mean. Lines with the same gradient are parallel, and parallel lines have the same gradient. So if I have line A, if I have this line, okay, AB, and let's say line MN, and we say these two lines are parallel. If these two lines are parallel, then we can basically say that then their gradients are the same. Okay, their gradients are the same. Meaning that if gradient over here is equals to 2, then automatically this side 2 is equals to 2. Okay. So with parallel lines, if the lines are parallel, then their gradients are the same. Okay. Now let's take a typical example of it. Let's check this one. We have these two lines. Let's have 3y minus 6x equals 9. And let's say 2y minus 4x equals, let's say, negative 12. If we check these two lines, we can determine whether these two lines are parallel or not. How do we do it? We have to check their gradients. If their gradients are the same, then automatically these two lines are parallel. So how do we check their gradient? We have to find the gradient over here. Last time, you remember we were able to find the gradient when the equation is given. We said to find the gradient when the equation is given, what we have to do is to make y the subject. If we make y the subject, then after that, the coefficient of x becomes the gradient of the line. That's what we said earlier, last time we met. So in this case, what we have to do with this line is to make y the subject to determine the gradient of each of them. So for the first one, first equation, we have 3y minus 6x equals 9. So let's make y the subject. So we have 3y here. Let's send this one to the other side. So we have 9 plus 6x, right? 9 plus 6x. So over here, we can divide through by 3 to make y stand alone. So here divided by 3. This will cancel this one off. So we have our y standing alone. Here, this will give us 3 plus, this will cancel this one, give us 2x over here. So that's what we are getting. Y is equals to 3 plus 2x. So after making y the subject in this manner, then automatically the coefficient of x is the gradient. So here, for this particular equation, our gradient for m is equals to 2. Because 2 is the coefficient of x. So this represents our equation 1. So equation 2. Now let's look at the gradient from equation 2 as well. The same procedure, we make y the subject from this section. So we have minus 4x here. We send it to the other side of the equation. So we are going to have 2y sitting here. We have minus 12 plus 4x. Okay, so this is what we are getting from our equation 2. 2y over here. So we are sending minus 4x to the other side of the equation. So we are getting 2y to be equals to minus 12 plus 4x. So the same approach, let's divide through by 2 to make y stand alone. So here divided by 2 and this side divided by 2. So these two cancel these two off. And we have y to be equals to, this one will cancel this one to give us minus 6. Okay? So we have minus 6 plus 2x. So this one cancel this one plus 2. Minus 2x. So you see that after making y the subject over here, the coefficient of x becomes our gradient. And therefore here you can say that our gradient m is equals to 2. Now we can see that gradient 1, which is from our first equation, is 2. And that of gradient 2 from our second equation is also 2. Therefore, we can confidently say that these two lines are parallel. Why? Because their gradients are the same. Because we say parallel lines are lines which have the same gradient. So these two lines are parallel. Okay? Because their gradients are the same. I hope this is clear. Now let's look at this particular problem, example, which is example 2. So we have find the equation of the line which passes through the point 2, 3. Now, equation of the line which passes through the point 2, 3 and run parallel to the line 2y minus x equals 3. Okay, this is the problem. Now, we know that for me to find the equation of a line, as we stated when we were dealing with equation of a straight line, we said we need is either we get what? 2 points on the line. Okay? It's either we get 2 points on the line or a point and a gradient. Then we can find the equation of that particular straight line. So here they said we should find the equation of the line which passes through the point this. Okay? So they have given us the point. And run parallel to the line 2y minus x equals 3. If that particular line is running parallel to this line, then it means their gradients are the same. That's why we said parallel lines have the same gradient. So if they have the same gradient, and we are saying that that particular line is running parallel with this line, then it means the gradient of that line and that of this one are the same. So it means what we have to do is we have to find the gradient of this particular line so that we will use that particular gradient to find the equation. To find the equation of the straight line using this particular point. I hope you get what I'm saying. Because they are giving us a parallel line, one of the parallel lines, and we know that parallel lines have the same gradient. And lines with the same gradients are parallel. So over here, this line has been given to us, which is parallel to the line that we are going to find the equation. So what we have to do is we have to find the gradient from this particular line. After getting the gradient over here, we can use that gradient with our point over here to find the equation of the line that they are talking about. Okay? So here what we have to first do is to find the gradient over here. So here we have 2y minus x equals 3. So we make y the subject to find the gradient. So we have 2y, we send this one to the other side. So we have 3 plus x. To get the gradient, we make y the subject. So we divide through by 2. So here by 2, 2, 2. So this will cancel this one off. Y is equals to 3 on 2 plus 1 on 2x. Okay? So in this case, after making y the subject, we always say that the coefficient of x, okay, after making y the subject, the coefficient of x is always the gradient. So in this case, this particular the gradient m is equals to 1 on 2, right? The gradient is 1 on 2 because 1 on 2 is the coefficient of x. Now, because this line is parallel to the line we are going to find its equation, it means that this particular gradient and the gradient of that line are the same, because they are saying that the two lines are all parallel. So with this gradient and the point given to us, we can peacefully find the equation of the line that they are talking about. Okay, so let's find the equation of the line that they are talking about. And we know that the equation of a straight line is given by y minus y1. This one is equal to our gradient multiply x minus x1. Okay, good. So our y1 and x1 has been given to us in the question, which are the points. Find the equation of the line which passes through the point 2, 3. Okay, the point 2, 3. So the point has been given to us, and these points are representing the x1, y1, as you can see over there. Our m is the gradient, but because they said this particular line, okay, is parallel to this one, our gradient is now half, because parallel lines have the same gradient. So here we have our y. Our y1 is 3. Our m is half. X minus 2, which was given to us in the question. We can solve this one nicely. Y minus 3. And let's expand the bracket. We have 1 over 2x. Okay. Half times minus 2 should give us minus 1, right? Good. So here we can simplify it by sending this one to the other side to find it. So we have 1 over 2x minus y. So minus 3 is over here. When this process becomes positive. And we have minus 1 here, so we are going to get a positive 2. As far as everything has moved, we are left with nothing but 0. So this is our equation. Half x minus y plus 2 equals 0. But you can see that this one is a fraction, right? So you can double them by multiplying 2 by 2. So when you multiply 2 by 2, we are going to have x minus 2y. Okay, because half times 2 gives us 1. So there's 1 here, but we don't write it. Then plus 4 equals 0. So this is our equation that they asked us to find. So they said, find the equation of the line which passes through the point 2, 3. Okay, the equation of the line passes through the point 2, 3. And that particular line runs parallel to the line 2y minus x equals 3. So it means that this particular line, 2y minus x equals 3, and the line x minus 2y plus 4 equals 0 are parallel. It means the gradient over here will be equal to the gradient over here. So here, if you make y the subject, the one we find, if you make y the subject over here, the gradient that we are going to get will be the same as making y the subject over here, and which is half. Okay, and this is basically what this particular question means. So find the equation of the line which passes through the point 2, 3, and run parallel to the line 2y minus x equals 3. So this line and the line that we have found are parallel, and their gradients are the same. And I hope this is clear. Okay, so this is what we have. We have our 3 9 expressions over here. There you have to try them on your own. The first one says show that the line 5y plus 3x minus 2 equals 0 and 15y plus 9x plus 12 equals 0 are parallel. So you have to show that they are parallel. And I hope you know the procedure from what we have done so far. Then the second part, we have the lines 2x plus 3y equals 7 and 4x minus y equals 7 intersect at the point M. So here we have a point of intersection. The two lines intersect at this point. And we know we have done point of intersection in our previous lesson. So the two lines intersect at the point M. Now the question is A, find the coordinates of the point M. So you have to find the coordinates of the point M, and I hope you know the procedure of finding the coordinates of point M. Then the B, we are determining the equation of the line passing through M. So after finding the coordinates of the point M, you have to find the equation of the line passing through the point M, which is parallel to the line y equals 3x minus 1. Okay, so the line is parallel to this one, and I hope from what we have done previously, what we have done so far, you can understand this particular problem and solve it nicely. Then the third question says find the equation of the line parallel to the line y equals 4x minus 5 and passing through the point negative 2, 3. Okay, so this is your program of the day, and I hope you solve all of them and submit them. Okay, thank you.